Assalamualaikum warahmatullahi wabarakatuh. My name is GaluhWidiP as the speaker of this research, and the member of team this research are Mrs. Ernawati Sri Sunarsi, Mrs. Rima Sri Agustin, Mrs. Kundari Rahmawati. We are from Building Engineering Education, Universitas 11 Maret, Surakarta. Indonesian population growth has increasing along with increasing development in the construction sector. In addition, food, clothing, and housing is also a basic requirement. The increasing demand for such building need for building materials has also increased. Thus, it must be available in sufficient quantities for building materials. Building materials that are often used in Indonesia is concrete. They use concrete as a building materials that continues to increase the availability of materials making up the greater concrete that would give negative impact for environment. This is one of negative impact the environment. The problem of sand mining by the Department of Irrigation, Mining and Natural Disaster Management said if sand mining will change in natural conditions, for example, loss of soil fertility due to loss of topsoil, drained land, and empty areas. Therefore, trees cannot be planted. So we need to another materials replace sand to save the nature. Sand replacement material is expected to have the same properties of physical and chemical composition, for example, glass. The glass used replacement of fine aggregate is from base. At 2013, the percentage of base glass, which is 1.7% of the overall waste, 64 million tons every year. Why waste glass as replacement fine aggregate? Because glass powder has element content same as sand. One of them is silica dihydroxide. That is a previous research. Flexural strength of concrete contain variation amount of waste glass acquired from numerous research. There are many change every variation of waste glass. So we can conclude that glass affected the flexural strength. The other negative impact that is more conflict at cement factory. Conflict between resident and investor of cement factory in Kendeng, Rambang. The plan was set up to provide employment opportunities for residents but caused serious environmental problems. The emergence of environmental problem is the health of the surrounding population. Poor environmental condition will eventually cause problems for the surrounding community, such as disease and damage to natural resources. So, in this research, cement will replaced by fly ash. Fly ash use replacement of cement is from PLTO waste. Because the percentage of fly ash which is as 8 until 9 million tons every year. This is previous research from Solanke and Petroda. The result obtained show that concrete by using variation of 20% fly ash is an optimal percentage that may increase the flexural strength of concrete equal to 11.0 0.08% of normal concrete. And so in this research, using a variation of 20% fly ash to replacement cement. There are research methodology using quantitative experiment and this a variation of waste glass and variation of fly ash. And the test we have two tests. They are flexural strength and subjectivity test. Flexural strength decrease in variation of 0 until 20% of glass powder and decrease in variation 30 and 40% of glass powder. And this is the result of flexural strength testing. Flexural strength increase in variation of 0 until 20% glass powder and decrease in variation 30 and 40% glass powder. The result of the initial subtlety testing, the minimum of initial subtlety testing at variation 20% of glass powder. Telkus said that concrete research has had subtlety levels but has the highest flexural strength. Because solid concrete will have greater strength and lower water absorption rate. And this is the result of secondary subtlety testing. The concrete research has had secondary subtlety decrease because the more glass powder content in concrete will reduce the absorption of water to the glass powder which is unable to absorb water, thereby reducing the field of water absorption. This is conclusion of this research. 1. The variation of the use of waste glass as a partial replacement of fine aggregate and fly ash 20% of waste cement, significant effect flexural strength and resorptivity of concrete. And 2. Waste gas as a partial replacement of fine aggregate that is equal to 20% with a maximum flexural strength about 2.943 MPa. 3. The minimum subtlety initial about 0.0076 mm per second square root, the percentage of variation of 20% glass powder, and a minimum of secondary subtlety about 0.0034 mm per second square root in the variation